So let's talk about a few things, three definitions before we start moving on to higher level stuff. There are two very important angles to talk about when it comes to looking at atoms along a carbon-carbon bond. The first is just the straight up bond angle. Now this you probably already know from a lower level chemistry course, and that's the angle formed between one atom, central atom, and the other atom around it. So in this case, this would just be the bond angle. The other angle, which you may be less familiar with, is the idea of the torsional angle. So that is the angle formed between this bond and this bond relative to this bond. Now, as drawn, this is kind of hard to see. So what we're going to use is what's called a Newman projection. So what a Newman projection is that we have two circles superimposed. Now, this is created by looking down the carbon-carbon double bond. So the first circle here is going to represent these three hydrogen atoms, and behind it is a second circle representing these three hydrogen atoms. Now, at the center of this Newman diagram are our hydrogens, or is our carbon. So if we were to look at that carbon, looking down the CH3s, we would see this picture. We'd see a hydrogen atom sitting up and two hydrogens sitting down. Looking down this carbon-carbon bond, what we see is that this hydrogen is here, this hydrogen's here, and this hydrogen is here. So this is the Newman projection. Your solid lines within the circle represent the carbon you're looking at. The circle behind it, which you can't see because they're eclipsed, is the carbon behind it. And these lines that you see coming out from behind the circle, they represent the atoms on the other side. The dihedral angle, or the torsional angles, represent the angles between these two hydrogens. Now we're representing them kind of off-centered, so this way it's easier to see. But as drawn, this would be a 0-degree dihedral angle, or torsional angle, meaning that the hydrogen and hydrogen are on top of each other. We would call this an eclipse conformation. Now, if we were to rotate this carbon here 60 degrees, we'd have what you'd expect to be a more stable conformation because the hydrogens aren't as close as they can possibly be. They're offset by 60 degrees. And the way we would redraw this picture, this way. So offsetting that back carbon, rotating it 60 degrees, gives us this nice conformation where the hydrogens aren't overlapping. So this is how a Newman projection works. Now, what we're going to talk about in later videos is the importance of this dihedral or this torsional angle. And it's important because it's going to dictate the stability of that particular conformation. There are preferred and undesirable conformations. Representing them and understanding what they represent in space is going to be important to understanding their stabilities.